Hi again. We are going to talk about the lumberjack graphs activity that you did yesterday in class. I want to take a look at this table of values, and if you were to plot this table of values, you would get a function that looks something like this, more or less. What I want you to notice about this table of values is that it ends up being the inverse of this function. This is log base 2 x. And this, as you might have guessed, is 2 to the x. They are inverses of each other, which means that they are a reflection over that line y equals x. That means that all of their x and y values are switched, and that every corresponding x value becomes every corresponding y value. So the point 1, 0, which is the x-intercept for the logarithmic function, is the point 0, 1, which is the y-intercept for the exponential function. So finding out what value of x would produce an output of -5, and how do you know? Well, what this is really asking is, to what exponent do I have to raise 2 to get to some answer? And the answer is, I have to raise 2 to the -5, I get 1 over 32. And sure enough, 1/32 would be down here, where x equals 1/32 and where y is -5 and x is 1/32. The domain of this function is going to be x greater than 0, and the range of this function is all y values. So it's all real numbers. Okay. These two graphs are related. Well, the domain and the range are switched. We talked about that just a minute ago, in that they're inverses of each other, so all of the x and y values are going to switch. So the domain of 2 to the x is the range of log base 2x. When we look at these three graphs down below, I want you to notice that what they have in common. They have three things in common. The first thing that they have in common is that they all go through the point right here, 1, 0. The second thing they have in common is that they all have an asymptote at x equals 0. The third thing that they have in common is that they all increase slowly. All right, now, if we look at these three equations, we look at y equals log x, y equals log 4x, and y equals ln x. Let's talk about which is which and why. Okay, we'll start at the top. That green function is ln x. How do I know? Because when y equals 1, x is not a whole number. Remember, I'm dealing with a base of e here, so when y equals 1, x is not a whole number, it's some irrational number, because in order to get e to something to equal 1, that something has to be an irrational number. Okay, now the blue graph is the dotted line of the graph of log base 4x. How do I know? Well, because of the point 4, 1. Now the red graph here is the graph of log x, How do I know? Because of the point 10, comma, 1. And the whole idea behind this is that what I'm looking at is log base B, result B equals 1. In other words, what would I raise B to get B? So what would I raise 4 to get 4? Well, I would raise it to 1. What would I raise 10 to get 10? I would raise it to 1. So how could you estimate log base 4, 6? Well, what that's really asking here, what that's really asking here, log base 4 of something is 6, so, wrong way. Here we go. What that's really asking is, what do I have to raise 4 to get 6? Well, 4 to the something equals 6. It turns out that answer is that x is approximately equal to 1.3. And sure enough, if I look on the blue graph, what do I have to raise 4 to get 6? Well, right here, the answer is 1.3. All right, now let's talk about transformations. If I were to take this blue graph and shift it to the right 3 units, my new equation would be g of x equals log base 4. Now any kind of transformation that happens left or right is attached to x inside the parentheses, and if it's moving to the right, I'm going to see subtraction because that's what the parent function for a transformation says. So it's going to be log base 4, parentheses, x minus 3, close parentheses. So this blue graph is going to shift to the right, all of those points, 3 units. And here, roughly, is my graph of that transformation, log base 4 of x minus 3. How will the transformation affect the x-intercept, the asymptote, the domain, and the range? Well, the x-intercept is going to change because it's going to be shifted to the right 3 units. So it's going to be 4, 0, instead of where it was originally at 1, 0. Okay, how will the asymptote change? Well, the asymptote also moves 3 units to the right. So though my graph isn't accurate, if I were to erase that and draw it properly, my graph now would have an asymptote where x equals 3 instead of where x equals 0. Now, the domain of my function is going to change also because, again, this has been shifted 3 units to the right. So my domain now will be all x's greater than 3 instead of before when it was all x's greater than 0. Now the range, well, the range remains unchanged. And that's true for all, this is a universal, for all transformations of logarithmic functions. What changes is the x-intercept, the asymptote, and the domain.